Hi everyone, welcome to this final tutorial on solving simultaneous equations. In this tutorial we'll be looking at the third and final method for solving, a method which is known as the elimination method. So when should we use the elimination method to solve a pair of simultaneous equations? This method is used to solve simultaneous equations when both equations are expressed in two-intercept form. In this method, the aim is to eliminate one of the variables, either x or y, in the equations so that you can solve for one variable only. Then, when you have that one variable, you can then use substitution to find the second variable. Let's look at a couple of examples and see how this method works. We'll start with some easier ones to begin with. Let's look at this first example. X plus 2y is equal to 5. Negative x plus 4y is equal to 1. You can see in this example that both of these equations are written in two-intercept form, so I must use the elimination method. Focus on the coefficients of x and y. If we look at the coefficients of y here, they are different values, 2 and 4. But if I look at the coefficients of x, I can see that the coefficient of x here is 1 and the coefficient of x here is negative 1. Now, even though one is positive and one is negative, they both have the same numerical value. So if I add these two together, I will get 0. X plus negative x gives me 0. So this method involves me adding these two equations together, and in the process I will eliminate x. Let's look and see how that works. Here I'm adding the two equations together. X plus negative x gives me 0. They cancel out. 2y plus 4y gives me 6y. And 5 plus 1 gives me 6. So I end up with a line which looks like this one. So 6y is equal to 6, which means that y must be equal to 1. Once I have this one variable, y is equal to 1, I'm going to substitute it into equation 1 and solve for x. Here is equation 1 again, x plus 2y is equal to 5. If I let y equal 1 in this equation, it becomes x plus 2 times 1 is equal to 5. 2 times 1 is 2, and x plus 2 is equal to 5. If I take my plus 2 to the other side of the equals, I will perform the inverse operation, which is minus 2. So x is equal to 5 minus 2, which is equal to 3. I now have my solutions for both x and y, and the solution to this pair of simultaneous equations is x is 3 and y is 1. This is the elimination method at work. Let's look at another easier example like this one here. Both equations are again in two-intercept form, so I must use elimination. If I look at the coefficients of x in both of these equations, they are different values. But if I look at the coefficients of y, they're the same value, positive 2. So if I subtract 2y from 2y, they will cancel out. And that means that if I subtract one equation from the second equation, I can eliminate y. Let's see how that works. Here's the equation here. I'm subtracting equation 1 from equation 2. 5x minus 3x will give me 2x. 2y minus 2y is 0. 23 minus 13 gives me 10. So 2x is equal to 10. So therefore, x must be equal to 5. Once I have this one variable, x, I can now substitute it into equation 1 and solve for y. Here's equation 1 again. 3x plus 2y is equal to 13. If I substitute x is equal to 5 into this equation, I'll get 3 times 5 plus 2y is equal to 13. 3 times 5 is 15, so 15 plus 2y is equal to 13. Now, when I move my positive 15 to the other side of the equals, it's going to become the inverse operation, minus 15. So 2y is equal to 13 minus 15. Therefore, 2y must be equal to negative 2. Now, if 2y is equal to negative 2, y must be negative 1. So now I have both of my unknown variables in this pair of simultaneous equations. X is equal to 5 and y is equal to negative 1. Let's look at another example now. These ones are a bit harder. Again, both equations are in 2-intercept form, so I must use elimination. Look at the coefficients of x. They're different values, 6 and negative 3. So are the coefficients of y. They're different as well. Here the coefficient of y is 1, and here the coefficient of y is 2. So what can I do to overcome this? If I multiply this y by 2, it will then be 2y. And I can subtract this 2y from this 2y to eliminate them. My solution here lies in me multiplying this whole equation through by 2 to get 12x plus 2y is equal to 18. Then the y's will have the same values and I can eliminate. Let's look at this. We're going to eliminate y and solve for x. As I said before, equation 1 is multiplied by 2 to get 12x plus 2y is equal to 18. I'm now going to call this equation 3. I then write down equation 2 just as it is again. What I'm going to do is I'm going to subtract equation 2 from equation 3. So I've got 12x minus negative 3x will give me 15x. 2y minus 2y is equal to 0. 18 minus 3 gives me 15. So therefore 15x is equal to 15. So clearly x must be equal to 1. Now I just go through the same process as I did before. If I know x is equal to 1, I can substitute it into equation 1 and solve for y. Here's equation 1 again. 6x plus y is equal to 9. If x is equal to 1, I have 6 times 1 plus y is equal to 9. 6 times 1 is 6. 6 plus y is equal to 9. When I take 6 to the other side of the equals, it becomes minus 6. So y is equal to 9 minus 6. Therefore, y must be equal to 3. So therefore, my solution to this pair of equations is x is 1 and y is 3. This is still the elimination method, except initially I had to multiply equation 1 by 2 first before I could eliminate. Now with this pair of equations, I could also do the same thing and eliminate x and solve for y. Let's look and see how that works. What I've done here is multiply equation 2 by 2 and call this equation 3. Equation 2 was originally negative 3x plus 2y is equal to 3. When I multiply it by 2, I get negative 6x plus 4y is equal to 6. I then write down equation 1 again, just as it is, and add it to equation 3. Because I multiplied equation 2 by 2, it meant that my coefficients of x were the same now. Here it's negative 6, here it's positive 6. So if I add these two values together, they will eliminate each other and be equal to 0. Negative 6x plus 6x gives me 0. So when I add these two equations, I'll get negative 6x plus 6x gives me 0x. 4y plus y gives me 5y. 6 plus 9 gives me 15. So 5y is equal to 15. If 5y is equal to 15, then clearly y must be equal to 3. Remember, this is the solution we got earlier. Now, I'll substitute y is equal to 3 into equation 1 and solve for x. Here is equation 1 again, but this time I'm going to let y equal 3. Take 3 to the other side of the equals and minus 3. 9 minus 3 gives me 6. If 6x is equal to 6, x must be equal to 1. I end up with the same solution. X is 1 and y is 3. So for this pair of equations, I could have done either method. Eliminate y and solve for x, or eliminate x and solve for y. In our next tutorial, we'll look at a few more examples of using the elimination method. I hope you found this useful and it helps you when doing your own examples of solving simultaneous equations using the elimination method.